Now I realized that I had made an error upon running the simulation and comparing the results with what I obtained in MATLAB. So if we go back to the equation, I have in lecture 3, I defined the symbol L as half of the length, not the whole length. So if I were to use, so if, sorry, so the expression for gravity is actually mass times g times half of the length of the rod times cos theta. So the mistake was that I had directly connected the signal of the whole length into the multiplication block. It should be half of the length that I'm connecting. So I'll use a gain block with the constant set to 0.5. Make sure that it's half of the signal that I'm encoding. And that should connect any error, and I'll run the simulation. And now the results are ready, and if I double click on the scope, I'll be able to view the results. Before I get into that, I hope you noticed, if I run it again, there's something called compiling going on, and that's where MATLAB generates the code to boil it down into equations and solve it using some simulation process or numerical methods. So that goes on behind the curtains, and we need not concern ourselves with such details, but that is what goes on behind the curtains, right? So let's view the results. So for so I modified the mass to 0.82 to reflect case C. So results are quite similar. Let's see what happened for case A as well. Mass is 0.5. Results should once again be similar to what we obtained in MATLAB. Now you see that because I have obtained the result, solved the same equation previously in MATLAB, I have something of a benchmark to compare my results with. Well, not exactly a benchmark, but I do have a means of ascertaining to a certain level that I have modeled the implemented and solved the ODE properly in Simulink. So until you are quite familiar with and confident of your block diagrams in Simulink and Simscape, that uh, solving it in MATLAB and comparing the results would be quite a nice way to ascertain that you have done implemented the model properly in Simulink. So that's it with regards to implementing ODEs and solving them. One additional thing that I'd like to discuss again is that we can plot any of these signals that are existing uh, within the block diagram, whether it be angular velocity, angular acceleration, uh, or any, yeah, simply any signal that you want that exists within the block diagram. Just make sure that you use proper unit conversions prior to connecting it to the scope block or to an existing scope block or a new one. If you don't use the proper unit conversions, then you will see some results and consider them erroneous, even though they aren't. So as one last demonstration, I'll show you how to plot angular velocity in RPMs. So what we have in this signal and any of its branches is angular velocity in radians per second. It needs to be multiplied by 9.54 in order to convert it into RPMs. Once again, if you do a simple calculation, you can figure out these constants by your own. simple unit calculations, and I'll rename this signal as angular velocity in RPMs. The upside to naming signals is one, of course, number one, it's clarity. You know what's going on inside the block diagram. And number two is because if you plot multiple signals on a single score block, then you can later activate a legend and see which signals are which. Right. Activate the legend by going into the view menu. Right. In the same manner, you can connect any other signal to the score block, but as I warned you early on, use proper unit conversions. So that's it with regarding to using Simulink to implement and solve an ODE. And the main advantages of using Simulink over MATLAB are not that really significant, but since it's a graphical programming or graphical modeling environment, keeping track of what's going on would be quite easier, especially when it comes to developing more complex models. And making modifications would be quite easy as well, I hope. But that's up for you to decide, and I think we have to consider on a case by case basis. But as I mentioned earlier on, why I really dis discuss Simulink in this lecture is because Simulink serves as the foundation for Simscape. And when it comes to Simscape, we don't have to concern ourselves with deriving equations and implementing them. We just need to focus on understanding the system properly, understanding its constituent devices properly, and understanding the interactions between them properly, and developing a model which consists of blocks for devices and interactions. So when we move on to Simulink, we won't have, so we can finally say goodbye to deriving ODEs. But this is what goes on behind the curtains. So with that said, I'll stop the video.